Right. Why is this? Um. Did this reset? Let me just check something here, guys. I'll put stream there. I'll put video. Right, right, right. Stream general. Okay. Tell me if I could view this video in a higher resolution now. I only see in 360p up to my end here. I want to change that. Right, so my man, we're working out all the kinks. Right, we're working out all the kinks. So just give me alright. Let's see, nobody could be in it. If all in the chat, let me know. If all seeing things, let me know. Is the stream stuck for earlier? Everything running smooth here. Like, alright, so I'm gonna write something on the screen here. Tell me if you've seen that. You've seen that little signature there? I would. Alright, so we have some topics here, right? We have more topics than this, but these are some of the common topics that we have. In order to do transformations, we had to do matrices. Alright, I see now man say, can I do Pythagoras' theorem? I can. Right, just give me a second. Yeah, in order to do transformations, you need to have a good knowledge of matrices. My matrices video is on this YouTube page. Go and watch it. Ismail, what are you doing here? Alright, Ismail. Preparing for CXCs, man, so you can stay if you want. So section 2 questions will be comprising of matrices, vectors, circle geometry, which I said we'll be doing tomorrow, travel time graphs, functions, a little probably quadratics. Yep. So like I see one person so far. Like I said, I promise we will do the probability and statistics and circle geometry tomorrow. I see one man say Pythagoras' theorem. I don't mind doing it. We could do a real quick run through of it. So there we go. Day 1. Alright, so we're doing Pythagoras' theorem, right? First things first, we need to know about the right angles. We know that how Pythagoras' theorem is with respect to right angles. We have to learn how to label the triangle. Easy come, easy go. We have two angles in the triangle, alpha and theta. Right, well, the first one is theta, the second one is alpha. How I label my triangle is very important. Depending on the angle we use in the question, I will label my triangle with respect to that angle. So we have some definitions, and just to save some time, I'll just copy across the definitions here. Right, so I'll be using a lot of my notes from before. So, cha-la-la-la. Alright. So like I say, I'm going to use plenty of my notes to save time, right? So the sides of a triangle, three sides in a triangle, they have a name. The hypotenuse is usually the longest side in the triangle, and it is the side opposite the right angle. So if I label this triangle A, B, and C, then my triangle, the hypotenuse, will be opposite the right angle. So my right angle stands at A, so my opposite will be BC. My hypotenuse will be BC. The opposite is the side opposite the angle being used in a calculation. You can only use one angle at a time in a calculation for trigonometry and Pythagoras' theorem. So let's just say I'm using the angle theta. If I'm using the angle theta, the side opposite theta will be AB. So AB will be called my opposite. And I'm putting in brackets, WRT means with respect to the angle theta. The adjacent is the side next to the angle being used in the calculation. If I'm using the angle theta in the calculation, AC is the side next to theta, so AC becomes my adjacent. And again, I'll put with respect to theta. Let me just say now, I'll put alpha in a different color, so when I label in it, you all will know which angle I'm working with. Let me say I use an alpha in my calculation. My opposite will no longer be AB, because the opposite, as defined, it is the side opposite the angle being used in a calculation. If I'm using the angle alpha in a calculation, then the side opposite alpha will be AC. So AC will be my opposite if I'm using alpha with respect to alpha. And the side next to the angle alpha is called my adjacent with respect to alpha. So this fella here will be my adjacent with respect to alpha. My hypotenuse remains the hypotenuse. He will forever remain the same regardless which angle I'm using in a calculation. So everybody should know this by now. We have with three trig ratios: sine theta, cosine theta, and tan theta is equal to. Have plenty of ways people remember it. Some of you will probably know SOHCAHTOA. Some of you probably know oh hell another hour of arithmetic. I'll show you the two. Whichever one sticks with you, then by all means go ahead and use that. Now these sine, they are accompanied by an angle. Sine of theta, cosine of theta, tan of theta. It have to be accompanied by an angle. I can't just go and type sine in my calculator. I'll give you all an example here. I can't just go and type sine in my calculator and get an answer. Well, my calculator will register 0, so I will get an answer here. Right? Sine of 0 is 0. But there are other calculators where you have to input an angle inside of there. So sine, cosine, and tan must always be accompanied by an angle. Angle is a number. At the end of the day is a number. 10, 15, 26, 14.2, whatever the number is. So from now until forever, sine of any angle will be opposite over hypotenuse. Cosine of any angle will be adjacent over hypotenuse, and tan of any angle will be opposite over adjacent. Now let me do a little example here. Oh, before we do the example, some of you will probably know this as SOHCAHTOA, C suka toa. Sine is opposite over hypotenuse. Cosine is opposite adjacent over hypotenuse, and tan is opposite over adjacent. Another way is, I'm gonna move this here. Another way is O L another hour of algebra, where the O represents opposite, H is hypotenuse, A is adjacent, H is hypotenuse, O is opposite, and A is adjacent. Either one you want to use, you could go ahead and use it. And the order of the trig ratios is sine, cosine, and tan. Whichever one you want to use, you could go ahead and use it. Let me try a little example here. Most important thing is to label the triangle. So let me just say, I have a triangle here. For example, I have a right angled triangle. Now we know it's a right angled triangle because we have the right angle sign. X, Y, and Z. I'm going to bring this fella in the middle here. Once you learn to label a triangle, calculations are going to be extremely easy, because you need to now pick one of the ratios to work with if we're using a ratio. Let me say this is the angle 24 degrees. This is the angle x degrees, and we have a side of the triangle being the, let me say this is 17 centimeters. I just making up, and I want to calculate the length of all the sides and calculate the size of all the angles. Well, we know how to calculate angle x. Angle x is just 90 take away 24, or some of you all will know it as 180 into 24 plus x. Right? I'm sorry, 180 take away 24 plus x. Let me write it down. 180 is equal to 90 plus 24 plus x, because 180 degrees is in a triangle. Another easier way to do this calculation, the sum of the two angles supposed to be 90 degrees. If u is 90 degrees, this right angle is 90 degrees. I need 90 more degrees to make 180 degrees. So the sum of those two angles must be 90 degrees. So another way you can see it is 24 plus x is equal to 90. Make sure you put your degree sign, please. So x degrees is equal to 90 take away 24. And I will always advise this. As smart as it is in mental maths, the calculator is the best way to go. Even I just use it all the time. 90 take away 24 is equal to 66. So x is 66 degrees. So one piece of the puzzle done complete. But I need to figure out what are the dimensions of my triangle now. So ask yourself, what angle will I use in my calculation? Let me just say, I decide to use the 24 degrees in my calculation. I'm going to use the definitions as stated above to figure out how I'm going to name these sides. So first things first, you can try and name the sides on your own while you wait for me. My hypotenuse is always opposite the right angle. So my hypotenuse is 17 centimeters here. So this fella here is my hypotenuse. Remember, we're using the 24 degrees. If I'm using the 24 degrees, the opposite is the side opposite the angle I'm using. I'm using the 24, so the side opposite the 24 is x, y. So you fella is my opposite. I don't even have to remember the definition for adjacent, because I just have one more side in the triangle. Brother man, by all means, use the adjacent. Now I'm looking to see what information I have in the question. I have information stating that I have the hypotenuse and I have an angle. I'm looking at my trig ratios. Each one of them, I am allowed to use an angle, sine theta, cos theta, tan theta. I am allowed to use an angle if I want to. But I'm looking at the sides, opposite hypotenuse, adjacent hypotenuse, opposite and adjacent. Brother man, it make no sense we use tan. For tan theta, I need to know what the opposite is and I need to know what the adjacent is. So I cannot use tan. For cosine theta, I need to know what the adjacent is and I need to know what the hypotenuse is. I could use it and I'll show you all why. Same thing for sine theta. So what I'm going to do, I'm going to complete each ratio with respect to the triangle. So if we complete our sine theta ratio, we can say sine theta is equal to opposite over, oh Jesus Christ, yes, no, right. Sine theta is equal to opposite over hypotenuse. Well, I know what theta is. Theta is 24 degrees. So sine of 24, opposite is xy, over hypotenuse is 17. I mean, I'm not here to show everybody how to do basic algebra skills. You all are in Form 5, you're supposed to know how to cross multiply and rearrange an equation. If I rearrange this equation, I will end up with one unknown, which is xy. If I have one unknown in any equation, I can solve for that one unknown. So for this ratio, I can use it. I have no problem using it. Let me turn to cosine theta now. Cosine theta is equal to adjacent over hypotenuse. The angle we're using again is the 24 degrees. My adjacent is xz over the hypotenuse is 17. Again, I have one unknown in this equation, which is xz. I can rearrange, I can cross multiply, do what I had to do, and calculate xz. What happens if I use tan theta? Tan theta is equal to opposite over adjacent. We know we're using the 24 degrees, but my opposite is xy, and my adjacent is xz. I don't know what xy is, I don't know what xz is, so I have too much unknowns in that question. So I know the two ratios that I have to use is sine and cosine to figure out the remaining sides of the triangle. So we cross multiply, we get 17 multiplied by sine of 24 degrees is equal to xy. So xy is equal to, come in the calculator. Now a very important thing I want everybody to do with their calculators, change your calculators to degrees. Everybody should be able to see the calculator properly there. Your calculator needs to be in degrees. You see this symbol on top here, DEG, that means degrees. I can change it to RAD and I can change it to GRAD. Those are just units of ways to measure angles, just like how you can measure distances in meters, kilometers, centimeters, and so on. You can use different units to measure angles. One unit is degrees, the next unit is radians. For maths, we only deal with radians. So back to the ratio. 17 sine 24, 6.914522. Approximate, no? 6.915 to 3 decimal places. 6.915 centimeters. Wait here now, to 3 decimal places. Don't be afraid to tell the examiner, yo, I'm making my approximation to 3 decimal places. Let me go back with you. Next side, 17 cosine of 24 degrees is equal to xz. So xz is equal to 17 cosine of 24. 15.530. 15.530. Again, to 3 decimal places. So I calculate xy, I calculate xz, and I calculate the angle x. So I finish this whole triangle here. But we have plenty of variations to do with this, But I want to do an alternative way. Let me just say, somebody decide to be a little fancy and say, well, you know what? I'm going to use the 66 degree angle in this triangle. Nothing wrong with doing that. Nothing wrong. But the size of your triangle will change. Whatever angle you're using, label your triangle with respect to that side. So again, going on redraw the same triangle. So instead of using the 24, I know this fella is 66 degrees. It's the exact same triangle I'm redrawing, but just doing the working in red to show the difference in the working, and you will get the same answer. Same exact triangle, I'm going to do the calculations as if I don't know the sides of the xy and xz. If I'm using the 66 degrees, well, yz will still be my hypotenuse. I'm looking for which side will be my opposite now. Remember, by the definition, the opposite is the side opposite the angle I'm using in the calculation. If I'm using the 66 degrees, the side opposite 66 degrees is xz. So you become opposite. This fella is my hypotenuse. I had to do no maths to figure out you will use the adjacent. So we're going again. I'm going to trial and error each one again. I say, well, sine theta, I know that it is opposite over hypotenuse. The angle I'm using is 66 degrees. So sine of 66 degrees is opposite, which is xz, over the hypotenuse, which is 17. One time I could cross multiply. 17 sine 66 is equal to xz. So xz is equal to, I know before xz, if I use the 24 degrees, my calculations will be a little different. But I know that xz at the end of the day is 15.530 to 3 decimal places using one calculation. So I'm using a different calculation here. I'm supposed to get the same thing. 17 sine of 66, 15.530. I get the same answer. So you have to just be very careful when labeling a triangle in the first place. Now you don't have to do two sets of working. Once you pick an angle, go ahead and calculate the triangle with respect to that angle. So I get xz is 15.530. 15.530 to 3 decimal places. I'm going to see what cosine theta is now. I know cosine is adjacent over hypotenuse. So cosine of 66 degrees is adjacent, which is xy over the hypotenuse, which is 17. So 17 cosine of 66 is equal to xy. Now remember, previously xy was 6.915, which I can see what we get here. 17 cosine of 66, cosine 66, 6.914522, just 6.915 to 3 decimal places. 6.915 forget to put centimeters, yes? Make sure I'm putting the centimeters as a unit, so people, you go lost marks if you don't put in the centimeters. Tyrell wicked examiners out there, and they will take away like a half a mark thing. No, still not. We'll be on the safe side, please. Centimeters. Alright, so if you want, you can try one for yourself, and at the end I'll come back to this question, okay? So if you want, you can take the time, try this one for yourself. Another right angle triangle, they 70 degrees, 24 centimeters, P Q R, angle theta. Tell me, all I want to do it or not? I will wait on the chat and see if anybody want to do it or not. All I'm going to do this question and then leave another one for all to do. I don't know how smooth the stream running. So Josh said no, don't do it. I will leave that for later, but I will come back to this and complete this question in the end, right? Now that was the trigonometry part. Well, let me do the Pythagoras' theorem part, right? Now this is an issue for a lot of students and a lot of teachers. How I might teach it might be how different to how your teacher teaches in school. But I sure everybody will learn that Pythagoras' theorem states that a squared is equal to b squared plus c squared. People say that, oh, yo, this is Pythagoras' theorem. Tell me, yes or no? Tell me if everybody learned Pythagoras' theorem is this from your teachers in school. A squared is b squared plus c squared. Nothing wrong with it, Nothing wrong with it at all. But I like to be a little versatile. What is A? What is B? And what is C? So I actually give you all the worded definition for what Pythagoras' theorem does, and then we formulate an equation with what we learn. So Pythagoras' theorem states, triangle there, yes. Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. So this is the worded definition for Pythagoras' theorem. Now if I were to take this definition and create a formula out of it, and I want a little bit of input in it. Now the stream from me talking to Alia, it will take a while to reach Alia. When I'll type it in chat, it will take a while to reach me. So it will take about 10-15 seconds to actually get that interaction between you and me. So just bear with me if I just sit down waiting for it to say something. The square of the hypotenuse is, well, the hypotenuse squared. That making sense to me. They say that this fella is equal to the sum of the square of the other two sides. So asking, what are the other two sides? We have the definition up here. What are the other two sides in a triangle? A right angle triangle. Like I say, it will take a little long time to get this interaction going on between us. So I really don't know how long it's taken for my voice to reach earlier. Let me check again here and see. To reach the tutorial now. Yeah. Well, the other two sides is the adjacent and the hypotenuse. The adjacent and the opposite. So this is the formula that I like to use. Hypotenuse squared is equal to opposite squared plus adjacent squared. And it's very versatile because I can use it with respect to any triangle, regardless how I label the triangle. Let's do an example. Basic right angle triangle. I put in that as A. Put in this as A. Put in this as B. Put in this as C. 3 and 4. Don't matter which angle I have, if I use an alpha or I use a theta. Let me see if we can complete Pythagoras' theorem for this question here. For Pythagoras' theorem, the hypotenuse squared, well, in this case, my hypotenuse is AC, no C. So I have AC squared is equal to, now what is my opposite? By definition, my opposite is with respect to some angle I'm using in the calculation. But for Pythagoras' theorem, I am not using an angle in the calculation. I'm just using sides. Well, given that I'm just using sides, it really doesn't matter which of the other two sides I pick as my opposite or my adjacent. And I'll prove it to you guys here. Let me just say I pick AB as my opposite. Well, the next side will be my adjacent, which is BC. AC squared is AB, which is 4, plus BC, which is 3. So I get AC squared is 16 plus 9, which is 25. So AC squared is equal to 25. I want AC, so I square root both sides. When I square root both sides, I get AC is equal to 5. Making sense? Or AC squared is equal to, we know AC is the hypotenuse. If I decided to say, well, you know what, I want BC to be my opposite. Remember, I'm just using Pythagoras' theorem. I'm not using no angles. BC squared plus the next side will be AB squared. So again, AC squared, it will no longer be 4 squared plus 3 squared. It will now be 3 squared plus 4 squared. Addition is, so it's commutative. 1 plus 2 is 2 plus 1. So AC squared is 9 plus 16. AC squared is 25. Square root both sides. And I get AC is equal to 5. So I'll put a note here. For Pythagoras' theorem, it does not matter which side is the opposite or adjacent. Mainly because we're not using an angle, and the definition I gave you all, the opposite depends on an angle. The adjacent depends on an angle. I'm not using no angle in Pythagoras' theorem, so we can pick whichever side we want to be as the opposite or the adjacent. It's just a matter of rearranging it, given the information we have in the triangle. So again, I'm going to put the next question here. I'm going to try it on our own, with a little variation. I'm going to draw a right angle triangle a little different now. L, M, N. theta alpha 6 and 8 centimeters. I will put 6 and 8. 6 and 10 centimeters. So go ahead, try and see if you could do this example here on your own. I will do the solution state as well. Right, let me move on again. The last thing we had to do in Pythagoras' theorem and trigs is how to calculate the angle using a trig. So calculating angles, and after you can go back and watch the video and pause and take down whatever examples you want to take down, right? So if you calculate some angles here, again, how do we have a right angle triangle? You know it. So we have a right angle triangle. I have an angle alpha and theta. And I have ABC. Just to name it. And I have the triangle 3, 4, 5. Is a valid triangle. Actually, I'm going to just put 3 and 4. I'll put 3 and 5. Right? Mixed up a little bit. So this is a triangle. I want to know what alpha, theta, and AC is. Now, you realize we have no angle to take away from nothing here. But I know alpha plus theta, they have to add to give me 90 degrees. So I can use trigs to calculate the size of our angle. So I'm going to try a thing. Let me say, I want to calculate alpha first. If I calculate an alpha first, well, alpha is the angle I'm using. If alpha is the angle I'm using, I need to label my triangle with respect to alpha. If I label my triangle with respect to alpha, this is my opposite. This is my hypotenuse. And this is my adjacent. And in the same breath, for those of you who want to try, label the triangle with respect to theta. So I'm watching the question here. I'm going to complete all trig ratios and I'm going to pick one that will give me the most information. And with the practice doing this, you all will realize, well, I don't really have to write down all the trig ratios. I can just look at the triangle, see what information I have, and okay, I'm using sine. Okay, I'm using cosine. Okay, I'm using tan. So sine of the angle alpha, I know it will forever be opposite over hypotenuse. Well, sine of alpha, I don't know what alpha is. My opposite is AC over 5. Here, we have two unknowns. Just all that. Alright, now we turn to cosine. See if cosine goes safely. Cosine alpha is equal to adjacent over hypotenuse. Again, I don't know what alpha is. Adjacent is 3, hypotenuse is 4. I'm sorry, 5. So you cooking with some gas. I only have one unknown, which is alpha. But how are we going to calculate alpha? Simple. If I show you one, I'll show you all. If we have sine of some angle, any angle, theta, is equal to some number k, then theta is sine inverse of k. How do we get sine inverse, you might ask? You see in the sine function here, present sine. Sine inverse is second function and then sine. I'll see sine to the minus 1. The same thing applies to cosine and the same thing applies to tan. If we have cosine of theta is equal to k, then theta will just be cosine inverse of the angle k, and well, the same thing for tangent. So in this case here, I actually have cosine of an angle is equal to a number. Cosine of alpha is equal to 3 over 5. Yes, it is a fraction, but it is a number. Well, alpha, by the little explanation I have on the top there, no one will close again, but I small thing. Yeah, so by that little working I have on the top there, alpha is equal to cosine inverse of the number, which is 3 over 5. Not bad. So we come on the calculator. Second function cosine 3 divided by 5, and we get an angle which is 53.13 degrees. And we say to 2 decimal places. I mean, now the next angle looking easy to calculate. If I have 1, I could get the next one. If I take this away from 90, take away 53.13, I get 36.87. I write another down on the side. 36.87 degrees. I know that is the size of my next angle by using our basic knowledge of the sum of the angles in a triangle add up to give now 180 degrees. But if I decide to use trigs to calculate the size of the angle theta, I'm supposed to get 36.87. So you can choose to work it out by using the knowledge of the sum of the angles in a triangle, or you can use it out using trigs. Doesn't matter. I want to calculate the angle theta now. So again, I'll have to relabel my triangle with respect to theta. So I will just put using theta, so you will have a little idea as to why the labeling changed for the triangle. Theta, this fella here is 3, which becomes my opposite. Remember, the side opposite the angle I'm using is the opposite. You will forever be my hypotenuse, which is 5, and the side next to the angle is my adjacent. And we have A, B, and C. I'll even this here as alpha. So I'm going to look at what information I have in the question. I'm not going on to the beat around and write down all the trig ratios because we're wasting time. If I look at the triangle, I see I have the opposite and I have the hypotenuse. So which ratio involves opposite and hypotenuse? Well, that's sine. So I can say sine theta is opposite over hypotenuse. Sine theta is equal to opposite, which is 3, over 5. I have sine of an angle is equal to a number. The angle is equal to sine inverse of that number, 3 over 5. So again, to get this calculation on the calculator, second function sine, open bracket, 3 divided by 5, close bracket. Supposed to get 36.87 is equal to 36.87. 2 decimal places. So basically, in a nutshell, that is Pythagoras' theorem on trigonometry in a nutshell. You all can go back, rewatch this piece of the video, and start to tackle questions on all your own. Now, questions like this, they will come as worded questions in the form of angles of elevation or angles of depression. It shouldn't be too difficult. Just a quick thing. An angle of elevation is always measured from your eye level. So let me say, walking on the road and I see a mango on a tree. And how you see the mango on the tree? You have to look up. From the time you start looking up, you start measuring an angle of elevation. So from your eye level to how much you look up to the mango, that is your angle of elevation. An angle of depression is just the opposite. If you're walking along the road and you see a man falling in a ditch and you start to watch down, from the time you start looking down, you start measuring an angle of depression. Alright? What other topic all you want to do now? Yekalim trying to make it easy. And like I said, I could go back and watch back this part of the video if I want. If I have any questions, I can always I'll link my email and my number in the end if I want to email me or if I want to WhatsApp me. Big about yourself. Yeah, so what topic we could do now? I think we should do our past paper. I think we could do our paper 1. I want to show you how to look up our paper 1 in no time at all. Alright, so I see a suggestion Whitney want to do completing the square. Let I go give a little crash thing on completing the square. That is one thing. Transformations. Yeah, we could do that. Like I say, Shane, a big topic. You can see if we could do that tomorrow. Akeem say bearings, and next man say functions. Alright, so we will go in order now. Somebody want completion of the square. We will do that first. The completion of the square are gonna make life real easy for all, yeah? If I show you 1, I show you all. Do the same thing for all. Usually when we complete a square, we take a quadratic and we make it look a different way. So we take ax squared plus bx plus c, which is a quadratic, and we take off your clothes and put on new clothes for him basically. Right? If I were to make that analogy. So let me say I have a quadratic. Any quadratic in the world. Let me say we have 4x squared plus 16x take away 11 is equal to 0. And I want to complete this square. Well, I've taken this fella here and I'm making him look a certain way. Most of the times, completion of the square, it takes a particular form. A into x plus h squared plus k, where a, h, and k are constants. Some exams you'll see p into x plus q squared plus r, where p, q, and r are constants. Regardless of how they tell you, put it, it's the same procedure we're going and execute. So if I've taken a quadratic and I'm making it a certain way, this is the first thing I want all to do. Let 4x squared plus 16x take away 11 be equal to, let me just say they want it in the form a into x plus h squared plus k, a into x plus h squared plus k. That's the first thing I want all to do. And it have 3 methods to do this. I'll show you now the most straightforward method. Next, if all I want to learn it off, or if all I want to understand it, it's up to all you. I'll leave in the left hand side as is. 4x squared plus 16x take away 11. What I'm going to do with the right hand side, every single time, the right hand side will be the same thing going down the road. Every single time. It will be a into, I'm going to expand x plus h squared. There's x squared plus 2xh plus h squared plus k. Like I said, every single time, it's the same thing we're doing over and over and over again. Sorry. I expand it again. 4x squared plus 16x take away 11 is equal to, I expanded the a now, ax squared plus 2ahx plus a h squared plus k. Again, the right hand side of this equation will always be the same thing going down the road. Now what do I do here? We write equate corresponding coefficients. Right, and I will just give you a little brief thing as to why we can do this. I have a certain number of x squares on the left, and I have a certain number of x squares on the right. and have an equal sign in the middle. The question says these number of x squareds are equal. It come like if Tom have 16 bananas on his table in the open, and Jane has a number of bananas in her bag, but the number of bananas on both tables are the same. Well, John's number of bananas is supposed to be equal to Jane's number of bananas. 16 is equal to 16. So if we represented her number of bananas as x, which is an unknown, I have 16 is equal to x. Kind of the same thing I'm doing here. I have 4x squared on the left, and I have ax squared on the right. So 4 is equal to a. I'm equating my x term now. I have 16x on the left. I have 2ah x on the right. I know what a is 4. 4 2s are 8. I divide by 8. 16 over 8 is 2. Finally, I have a constant. My constant is negative 11 is equal to ah squared plus k is my constant on the right. Right, so I just wanted you to remember this. A is a constant, h is a constant, k is a constant. So when I combine them with any number of operations, I will still get a constant. They are numbers. I know what a is, I know what h is. So minus 11 take away ah squared should be equal to k. Just move the ah squared on the left. So minus 11 minus a, which is 4, h squared, which is 2 squared, is equal to k. Minus 11, I'm going to my calculator. I just want to do it in this line here. Minus 11, take away 4 into 2 squared, minus 27. So I calculated a, h, and k. So I can say, as you seen, 4x squared plus 16x minus 11 is equal to a into x plus h squared plus k. In this case, k is negative 27. So I'll just put the minus 27 there. That's it. We're done with example. Again, you'll see how the procedure is exactly the same thing. Let me say we have now 3x squared minus, Jesus Christ, 3x squared minus 2x plus 4 is equal to 0. And I want to complete this square. Let this fella equal to a into x plus h squared plus k. The last example I will do, I will do it with the variation p into q plus r squared plus p into x plus q squared plus r. Same thing again. My left side change, but my right side going to be remaining the same thing. My left side becomes 3x squared minus 2x plus 4. But my right side, if you realize, is the same thing. A into x squared plus 2xh plus h squared plus k. Again, 3x squared minus 2x plus 4 is ax squared plus 2ahx plus ah squared plus k. Same thing. This line, and this line is the exact same thing as this line, and this line. Again, equate corresponding coefficients. And equate corresponding coefficients. is the same procedure. I have a certain number of x squares on the left, I must have a certain number of x squares on the right. I have 3 of them on the left, and I have a of them on the right, so I get 3 is equal to a. What about my x terms now? I have minus 2 on the left, I have 2ah on the right. I know what a is. A is 3. Minus 2 is equal to 2 into 3 each. 3 2s are 6. Minus 2 divided by 6 is minus 1 over 3. And lastly, it will be my constant. My constant on the left is 4. My constant on the right is ah squared plus k. Move the ah squared across, is equal to k. I know what a is, I know what h is. 4 take away 3 into minus a third squared is equal to k. And I just type in my calculator. 4 take away 3 into negative 1 over 3 squared is equal to 3 and 2/3, or if you want to change it to mixed number, improper fraction, 11 over 3 is equal to k. So the last line we can say 3x squared minus 2x plus 4 is equal to a into x plus h, and this time h is negative a third, squared plus k. That's it. You're welcome to here. Let me do the last one with a little variation. Now you can test yourself. X plus h squared is x plus h multiplied by x plus h. But there's an easy way to expand this here, and most of my students at least know how to do this. But for those of you who I never teach before, watch how to expand it very, very easily. If I have to expand, a plus b squared, well, we all know this is a plus b into a plus b, which is a into a plus b into a plus b, which is a squared plus ab plus ba, but ba I can write it as ab plus b squared. A squared, I have ab and ab, that is 2ab plus b squared. But we all supposed to know how to expand a bracket. But watch the easy thing here. A plus b squared. Square the first term. Multiply the two terms by each other. A and b, multiply them by each other. We get ab. And then multiply by 2. We get 2ab. Square the last term. That's it. Do another example with numbers this time. X plus 3 squared. Square the first term. Multiply the two terms by each other. 3 by x is 3x. Then multiply by 2. 3x by 2 is 6x. Square the last term. That's it. Minus sign any mixed thing now. 2x minus 4 squared. Square the first term. 2x squared is 4x squared. Square the first term, square the second term. Alright, 2x, when I square that, I get 4x squared. Multiply the two terms by each other. 2x by negative 4 is negative 8x. Double it. Negative 8x by 2 is negative 16x. Square the last term, minus 4 to be squared is 16. That's it. So you could keep practicing these things here. That is how I could have jumped from this line to that line down there. You can literally pick up any question and completely square on it. Any question you want and completely square on it. we got on completion of the square Whitney. And everybody else who everybody we got on completion of the square. Yes or no? Come on. Type it up in the chat. I need to know. We're gonna do some functions after. Functions wouldn't take long to do. Come on. Okay, let's put up our next example here for let's try. Complete this square for me when all I want 2x squared minus 11x plus 4 whenever I want. Alright. Jesus Christ. Alright. I see a man say functions. Hakim say he want no. Hakim say bearings. Fireball. Who is Fireball? Fireball, what's his name? Fireball, yes. Jesus Christ. We see dark skin, brownie skittles and chat. Yeah, boy, Fireball. I don't know if it's a boy or a girl. So yeah, Fireball. Functions. Functions is just terminology. If I have f of x, this just telling me that I have a function in terms of x. A function in terms of x. If I have g of w, this is a function in terms of w. If I have h of a, this is a function in terms of a. Equal. For example, 2x plus 4, x squared minus 3x cubed plus 11. At the end of the day, all I have is x's inside of there. For example, for the second one, 2w plus 4w squared minus 3w cubed plus 11. At the end of the day, all I have is w's inside of there. Last one, you can make a guess. Just an example, 2a plus 4a squared minus 3a cubed plus 11. I can make up any expression. As long as I only have x's for the first one, I only have w's for the second one, and I only have a's for the third one, I good to go. So if I have, for example, very simple ones, f of x is 2x plus 1. Sometimes a question will say, well, what is f of 1? If you realize they jump from here to here, I replace x with 1 on the left hand side. I could just replace x with 1 on the right hand side. 2 into 1 plus 1. 2 and 1 is 3. But what f of 2? Well, I replace x with 2. This will be 2 into 2 plus 1. 2 2s are 4 and 1 is 5. What about f of 3? That's 2 into 3 plus 1. 3 2s are 6 and 1 is 7. How about if I have f of a? I replace, instead of a number, I have a letter there. So this could be 2 into a plus 1, which is 2a plus 1. I don't know what a is, so I'll leave it like that. What about f of b minus x? So this could be 2 into b minus x plus 1. It's just replacing whatever I have in my bracket, replacing that variable everywhere I see it on the right hand side. So it's the first concept we will learn. Next concept is calculating the inverse of a function. And these questions come every year. Calculating the inverse of a function. Again, if I have f of x is equal to 2x plus 1, the first step I want us to do, let y equals the function. So let y equals 2x plus 1. That's the first thing, every single time. Next, interchange x and y. Interchange x and y. So wherever I see y, I put in x. Wherever I see x, I put in y. X will be equal to 2y plus 1. Lastly, solve for y. Move the 1 across. X minus 1 is equal to 2y. Divide by 2. X minus 1 over 2 is equal to y. Last, let f inverse of x be equal to the expression, which is x minus 1 over 2. Step 1, let y be the function. Step 2, interchange x and y. Step 3, solve for y every single time. So this here will take a little bit of knowledge on how to rearrange a formula. So you need to know to do this. Lastly, composite functions. The first thing I showed you all in functions here is directly related to composite functions. If f of x is equal to 2x plus 6, just give me a second, okay, people. I thought, sorry about that day. Sometimes you just can't ignore people call, huh? Alright. So yeah, as we were saying, composite functions directly related to the first thing I just now showed. If f of x is so by so, and g of x is our next function, still a function of x, but a different. Let me say g of x is 4x minus 9. Different. And I want to know what f g of x is. Take it step by step. What is g of x? I know what g of x is. G of x is 4x minus 9. So I just replace in g of x with 4x minus 9. This is f of 4x minus 9. So f of 4x minus 9 is related to the first thing I showed you here. If I have f of x and I want f of 1, I replace x with 1. This one, if I have f of x and I want f of 4x minus 9, I must replace x with 4x minus 9. So this is equal to 2 4x minus 9 plus 6. 8x minus 18 plus 6. 8x minus 12. This is f g of x. What about gf of x? G f of x. Looking at the function, I know what f of x is. F of x is 2x plus 6. So this is g of 2x plus 6. If I have g of x and I want g of something else, I must replace the x with something else. So this is equal to 4 into 2x plus 6 minus 9. 8x plus 12 minus 9. 8x plus 3. And this is g f of x. Right? And these things take some practice here to do. Functions have plenty of things to do with drawing curves and things, but when we do we past papers, probably today or tomorrow self, we go tackle them past paper questions. Because if I show you one, I show you all. Right, I see our next man said bearings and then transformations. Alright, no problem. Now, bearings, it needs good knowledge of your sine rule and your cosine rule. I don't want to really go in depth in that. So, based on the consensus of the chat, I have a lot of you all here. Bearings or transformations? Which one do you all want to do more? Or which one do you all need knowledge on more? Bearings or transformations? Because both of them are two big topics. And we're going to take a little while to go through the two topics, about 45 minutes to an hour or so. So I need the input, I need the input. How much of all I want to go through the bearings, how much all I want to go through the transformations. Right, so looking like bearings is the wood. Alright. All bearings are measured in a clockwise motion from the north cardinal point. A bearing has 3 digits. If a bearing is more than 100 degrees, then we write the bearing as like 104 degrees. If the bearing is less than 100 degrees, then we put a 0 in front of the number. For example, 045 degrees. But if the bearing is over 100, 216 degrees. Okay? So, do the example here. Okay, wrong direction. This is not line. I'll measure a bearing in this direction here. So this could be my bearing here. Theta, degrees. Right? That's how we measure the bearing. Now we know from north to east is 90, from north to south is 180, from north to west is 270, and from north back to north is 360. Another thing we need to learn that you're supposed to have knowledge on is alternate and corresponding angles. So bearings have a lot to do with parallel lines, because I can literally construct a note line from any point, and all note lines are parallel to each other. So when that happens, and I have a line cutting a pair of parallel lines, I form some angles. Most important, I'm going to do the next one. It will be easier to see the next one. What we're looking for a Z. So my angle here, let's say this is angle A and angle B. They are called alternate angles. So A is equal to B, and these are alternate angles. I also form angles here. Let's say this angle here is X, and this angle here is Y. I will have X is equal to Y, which is corresponding angles. The best way to do bearings is by examples, but before we do the examples, you'll need to know about the sine rule and the cosine rule. So let me do. We know that how the rule that involves right angle triangles are Pythagoras' theorem and trigonometry, sine, cosine, and tan. But suppose we do have a right angle triangle. We had to know what to do. So this is going to be the sine rule. If I have a triangle A, B, C, and I call in each of the angles their respective sides, the vertices. So for example, this fella here will be angle A, this fella here will be angle B, and this fella here will be angle C. I'm going to label the sides as little a, little b, and little c. And I label the sides with respect to the vertex opposite that side. So the vertex opposite little a is big A, the vertex opposite little b is big B, and the vertex opposite little c is big C. So my sine rule states that A over sine of A is B over sine of B is equal to C over sine of C. So if I put this in words for you guys, the ratio of a side to the sine of the angle opposite that side is equal for all triangles. This can be applied to a right angle triangle as well. What I like to do, I like to label each one of these things here 1, 2, and 3. So I have 1 is equal to Jesus Lord. 1 is equal to 2 is equal to 3. I label them 1, 2, and 3 respectively. Now, when doing questions involving a sine rule, we just have to pick a pair. And we will pick the pair based on the information I can gather from a triangle. So let me go and get an example here. a sec. Let me just grab an example here for you guys. In the meantime, I'll listen in if anybody have any questions they want to ask. Sine rule, cosine rule, tra la la la. Alright, we'll see. Let me just redraw this triangle, right? I'll get one already. So, for example, let me say we have a triangle here. Similar triangle. Let me draw it a little accurate now. So this here is 104 degrees. This here is 64 degrees. And this here is theta. This here is x centimeters. And this here is 11 centimeters. This is A, B, C. And this is y centimeters. And your mission is to calculate the size of the angle theta, the length of the side x and y. First thing we have to establish, brother man, this is not a right angle triangle. So whenever we have a non-right angle triangle, the first thing that I want to click, sine rule and cosine rule. In this case we are going to do the sine rule. I'll show you what the cosine rule is after. So in all instances, I want everybody to complete the sine rule for that triangle in question. So if I complete the sine rule states that the length of a side divided by sine of the angle, which is directly opposite that side, is equal for all sides and angles in a triangle. So one part of the sine rule in this case will be x and 64 degrees. So x over sine of 64 degrees is equal to, another relationship will be y and theta. Y, Jesus Christ, y over sine of theta. And finally the last piece will be 11 and 104. 11 over sine of 104 degrees. So I have 1 is equal to 2 is equal to 3. It's your job now to look at these pairs. I can either pick 1 and 2, 1 and 3, or 2 and 3. It's up to you to determine which one will give me one unknown. If I pick 1 and 2, I don't know what x is, I don't know what y is, I don't know what theta is. If I pick 1 and 3, I don't know what x is, that's the only unknown. So I can pick 1 and 3 to see if I can calculate the value of x. So again, this will require you to have knowledge in rearranging a formula. So I'll have 1 is equal to 3. 1 is equal to 3. X over sine of 64. And remember, I can calculate this angle, this number on my calculator. Just press sine, press 64, and I get the angle. Well, I get the number. 11 over sine of 104. I'll rearrange a little bit. X is equal to 11 sine of 64 degrees all over sine of 104 degrees. Jump on your calculator. 11 sine 64 divided by sine of 104. I get 10.189 centimeters, and this is the 3 decimal places. Now it's time to figure out how I'm going to calculate y and how I'm going to calculate theta. Luckily, I know that the sum of the angles in a triangle is supposed to be 180 degrees. So 64 plus 104 plus theta is supposed to be 180 degrees. Please put your degrees next to your angles. Theta is 180 degrees. Take away 64 degrees. Take away 104 degrees. So theta 180, take away 64, take away 104 is equal to 12 degrees.
Where's Auntie?
I don't know. 12 degrees. So given that theta is 12 degrees, I can plug in theta for part 2 in my sine rule. So my sine rule now, if I pick 1 and 2, 1 and 2 I still have 2 unknowns, x and y. If I pick 2 and 3, I have 1 unknown, because I know what theta is now. So if I say 2 is equal to 3, I'll have y over sine of 12 degrees is equal to 11 over sine of 104 degrees. Cross multiply a little bit. 11 sine 12 over sine of 104. And this is equal to, jump on the calculator, 11 sine 12, 11 sine 12 divided by sine of 104, 2.357 centimeters. Again, to 2 decimal places. Now we got next question. Now you see this fella is 53 degrees. This fella is theta alpha 5 centimeters, 7 centimeters, x, y, z. This is y centimeters. Your mission again, calculate the length of the missing side and the size of the 2 missing angles. Not a right angle triangle, jump on the sine. Complete the sine for the triangle. I will have the side divided by sine of the angle, which is opposite that side. So the first piece will be 5 over sine theta is equal to 7 over sine 53. It doesn't matter which order you put it in, it doesn't matter. Is equal to, the last one will be y over sine of alpha. Again, I'll have 1 is equal to 2 is equal to 3. Well, if I do this, I can pick 1 and 2, because 1 and 2 will give me just one unknown. which will be theta. But you had to be smart. You had to know how to rearrange. So if I have 1 is equal to 2, I will have 5 over sine theta is 7 over sine 53. Rearrange a little bit here. Cross multiply. 5 sine 53 is 7 sine theta. I want sine theta. Divide by 7. 5 sine 53 all over 7 is equal to sine theta. Let me make life easy. I can calculate what 5 sine 53 is divided by 7. 0.57. So 0.57 is equal to sine of theta. Back to the old time tricks days. If I have sine of an angle is equal to a number, then the angle is equal to sine inverse of the number. So theta is equal to sine inverse of 0.57 of 0.57. You get 34.75 degrees. I have theta. I can figure out what alpha is. 53 degrees plus alpha plus theta is supposed to be 180. Alpha is equal to 180. Take away 53. Take away theta. I know what theta is. Theta is 34.75 degrees. So alpha is 180. Take away 53. Take away 34.75 is equal to 92.25. So now I can pick 2 and 3. So I have 2 is equal to 3. If I have 2 is equal to 3, I will have 7 over sine 53 is equal to y over sine of alpha, which is 92.25. Cross multiply 7 sine of 92.25 over sine of 53 is equal to y. 7 sine 92.25 divided by sine of 53, 8.758 centimeters. Alright, like I said, you can always go back and review these things. So here what you're gonna do, come up with any questions that I have, taking a small break, taking a 5, I'm talking for an hour and a half straight. So we're taking a small 5, we're going to resume the stream in about 10 minutes. So take a little 5 now, and we'll be back soon. Alright, and we are back. Alright, so see, good few people leave, boy. No, small thing. We go organize yourself to suit. So, in sine rule, really easy to apply. All you have to do is complete the sine rule for the non-right angle triangles and figure out which pair will give us just one unknown. The most you will have to do is use your knowledge for the sum of the angles inside of a triangle, as well as rearranging your formula. Now we go on to the cosine. The cosine is a little more difficult, but it has a pattern to it. So the cosine rule, cosine rule, again, if I have a non-right angle triangle, labeling it the same exact way as before, where we have A, B, and C. This is little a, this is little b, and this is little b, and this is little c. And each vertex is the name of the angle, so the vertex at A will be angle A. The question states that A squared is equal to B squared plus C squared minus 2 BC cosine of A. The only thing I want you all to take out from this, the letter that starts the equation is the angle that ends the equation. Everything else is just filling in the other sides. So again, I'll say it again. The letter that starts the equation is the letter that ends the equation with respect to our angle. So, we have the variations for this. I can say the next one will be B squared is equal to something, but I know it must end with cosine of B. To fill in the rest is exactly the same pattern as above. It will be A squared plus C squared minus 2AC. So challenge yourself for this one. C squared, what must the equation end in? It must end in cosine of something. Figure it out. Alrighty. And I'll give you all 10 seconds to figure out what goes in between there. Cool. If I figure it out, good job. It will be B squared, well, you can put A squared first, plus B squared minus 2AB cosine of C. So let me do our application here. Now you might ask yourself, what is the point we learning sine rule and the cosine rule? Well, we will figure out what is the scene. Alright, Ethan, what is the scene? Give me real trouble, come to give me more trouble again. Nice. X centimeters, 7 centimeters, 51 degrees, and 12 centimeters. X, Y, Z. And we're going to have a little play on the, let me change it, put this as X. We're going to have a little play on the letters, the rearranging of the letters in this question here. So first things first, it is a non-right angle triangle. So the first thing that must come to mind is, okay, sine rule or cosine rule? It's easier to complete the sine rule for a triangle than completing the cosine rule for a triangle. Let's complete the cosine rule and see what happens. I'm sorry, the sine rule and see what happens. Well, the sine rule states that it'll be 7 over sine I didn't label the angles, theta, alpha. 7 over sine theta is equal to 12 over sine alpha is equal to x over sine of 51. 1 is equal to 2 is equal to 3. As you can see, any combination of pairs will give me more than one unknown. If I pick 1 and 2, I don't know what theta is, I don't know what alpha is. If I pick 1 and 3, I don't know what theta is and I don't know what x is. If I pick 2 and 3, I don't know what alpha is, I don't know what x is. So regardless which pair I pick, I get 2 unknowns, which is not feasible. So therefore, in this case, there's not enough information to complete the sine rule or to use the sine rule as yet. So we turn to the cosine rule. Now, given that we can have the variations for the cosine rule, I'm going to complete all variations for this particular triangle. I can see that here was the scene. X squared is equal to, if this is little y and this is little z, x squared is equal to y squared plus z squared minus 2yz cosine of x. And I want you all to develop this pattern for the sine rule and the cosine rule. The cosine rule especially. It's a very simple pattern to follow. Again, the letter that starts the equation is a side. The letter that ends the equation is the same thing, but it's an angle in the end. Let me input some information here. I don't know what x squared is, so it stays like that. I know what y is. I know what z is. Minus 2y z cosine, and I know what the angle x is. The angle x is 51 degrees. So I can actually calculate the number on the right hand side of the equal sign. So x squared is equal to, and be very, very wary when we jump in the calculator here, okay? Input the numbers as you see them with the brackets. I have 12 squared plus 7 squared. Take away 2 into 12. Sorry, that's 11. 2 into 12 into 7 cosine, open bracket, 51 degrees, close bracket, is equal to 64.274. That is x squared. Square root both sides, just like in Pythagoras' theorem. And we get x is equal to, if I square root this here, the square root of 64.274, 8.017 centimeters. Now, I want you all to complete this exercise on your own. Complete the cosine rule using y as the beginning and then using z as the beginning. See what happens. But in order to complete the rest of the triangle, I can now fill in some missing information that I have in my sine rule. I now know what the entire 3 is for my sine rule. 3 will now be 8.017 over sine of 51. If I combine 1 and 3, I get one unknown, which is theta. If I combine 2 and 3, I get one unknown, which is alpha. Alright, now you all can take your time and finish off this question using the sine rule and using the cosine rule, and we go dive into the bearings now. Now all bearings questions, they will have a diagram accompanied with them. I will say 9 times out of 10 the bearings questions are in the form of sine rules and cosine rules. So let me see what we could get here. Supposed to have a worksheet for bearings. Let me see. Okay, good. Alright, so I'm going to post a link for a PDF in the chat. Right, you all can go ahead and click the link. It's a clickable link, right? Nothing wrong with it. You can click it. Go ahead and click the link and it will direct you to a PDF document involving bearings with worded questions and diagrams. And we're going to start from the first one. So question 1. The diagram below, which is not drawn to scale, represents the position of 3 mobile phone masts. Mast Q is on a bearing of 100 degrees from mast P and is 40 kilometers away. The bearing of mast R from mast Q is 150 degrees. Masts P and R are 66 kilometers apart. Use the information in the diagram to establish the size of the angle PQR. Okay. Hence, find the bearing of mast P from mast R. Cool. Now, in these questions here, I think there are answers at the end of this book. There are answers at the end of this worksheet. So I'm just going to do the first one. I'm going to leave the rest for you all to complete on your own. You have the answers, and when we dive into more past papers, we could see what's going on with these things here. So let me redraw the diagram. I have now draw a diagram to the middle of a page. Always when you are drawing a diagram, put the word let, meaning I am going to let the diagram be whatever I want it to be. I can put in a frog in the diagram if I want to. I am letting the diagram be so by so. Draw your knot lines from each of your points. Right, and my knot lines wouldn't be too accurate because I don't know why one note does play up so much for. Right, but draw it as accurate as you can. I go draw it freehand, right? So this is one knot line. This here will be 2 knot lines. This here will be 3 knot lines. So this is P, this is Q, and this is R. This is 40 kilometers. This is 66 kilometers. This is 100 degrees. Not, and this bad boy here is 150 degrees. So the first thing I want to calculate is the angle PQR. Now when they give you an angle like this, stated that calculate that angle, it's usually the angle in the middle. So PQR is the angle made between PQ and QR, which is this angle here. Now because I said let, I can name this angle anything I want to. I can say this angle is theta. So let me see what we can do here. If you remember the laws that we learned with respect to corresponding angles and alternate angles, we can make life like this very, very simple. Angles in a straight line are 180 degrees. If I were to extend this line backwards, this angle here will be 80 degrees because angles in a straight line are 80 degrees. My knot lines by Q and P are cut by the line PQ. Because I have a pair of parallel lines being cut, I form alternate angles and corresponding angles. So this 80 degrees there will be the same as this 80 degrees here. And another piece of knowledge is angles in a circle is 360 degrees, or angles about a point are 360 degrees. So PQR, I can say that how. Let me call this fella here alpha. And we could call it x if we wanted to. So alpha is equal to 180 degrees, take away 100 degrees. And you put your statement y. Angles in a straight line sum to 180 degrees. So alpha is equal to 80 degrees. We can now say that alpha is equal to x, y corresponding angles are equal. Now we can say that how x plus 150 degrees plus theta is equal to 360 degrees. And to me, the nicer statement is angles about a point sum to 360. Angles about a point sum to 360 degrees. So theta is equal to 360, take away 150, take away 80. Jump on your calculator. 360, take away 150, take away 80, 130 degrees. And theta is equal to PQR, which is 130 degrees. Now the next piece of the question states, hence find the bearing of mast P from mast R. So I want the bearing of P from R. Based on the diagram, remember we measure bearings from the north line in a clockwise direction. So from R, I want to see how long do I have to go until I get to P. That's the bearing I want. Let me call this bearing here beta. Right, beta is a Greek symbol, beta. So make life easy. I can name this angle inside of here y. I can name this angle inside of here z. Now, most bearing questions, if not all bearings question, will always include some calculation with sine rule or with the cosine rule. So I already calculated theta. Sorry. With the practice, you all will see which rule to use where. You can use the cosine rule. Not as yet, no. Needed that angle there. So by so, right, we can use the sine rule then. Yeah, we can use the sine. So let me just pull this diagram a little bit to the side to give yourself some more space. And I have the luxury of doing something like this, but you all don't, so that locks. In part 2, I'm calculating the bearing of P from R, and that's the bearing, the angle beta. So using the sine rule, I will have Q, well, I'm going to put in information. 66 over sine of 130. That is one part of the sine rule. The next part of the sine rule will be QR, and I'm going to label that little p, little q, and little r. P over sine of z. which is equal to 40 over sine of y. This is 1 is equal to 2 is equal to 3. If I get y, I can use some magic and figure out what the angle is, the angle beta is. 1 is equal to 3 will give me one unknown, which is y. I can solve for my one unknown. If I have 1 is equal to 3, 66 over sine of 130 is 40 over sine of y. Cross multiply, 66 sine of y is 40 sine of 130. Divide by 66, sine of y is 40 sine of 130 divided by 66. I could work out all that as my calculator. 40 sine 130 divided by 66, 0.464. So if sine of an angle is 0.464, then y will be sine inverse of the number. Sine inverse of 0.464, 27.65 degrees. Now I'll get the angle y. If I could figure out what this angle is here, let me call this angle inside of here A. If I can figure out what the angle A is, then I can figure out y plus A plus beta supposed to be 360 degrees. Again, this will require knowledge of corresponding and alternate angles. I'll do it in a different color so you will see it. And yes, these are how bearings questions are. They can get very confusing, but I get good at it because I practice. You all can do the same. If I extend this line at Q, I will formulate an angle here, and I'll call this angle little b. So A is equal to B because of corresponding angles. So let me just pull this working here. Pull this working down here. And I'll bring the bearing in the middle, the diagram in the middle. So let's pull it up. Cool. So A is equal to B because corresponding angles are equal. A is equal to B because corresponding angles are equal. Well, B is equal to 180 degrees, take away 150 degrees, which is equal to 30 degrees. And we state why. Because angles in a straight line sum to 180 degrees. So B is equal to 30 degrees, which is equal to A, and we state this is because of corresponding angles. So beta plus y plus A is equal to 360 degrees. And we state angles about a point. Sum to 360 degrees. So beta is equal to 360 degrees, take away y, which is 27.65 degrees, take away A, which is 30 degrees. Jump on the calculator. 360, take away 27.65, take away 30, 302.35 degrees. Remember, bearing has 3 digits. So what I want you all to do, express your bearing to the nearest whole number. So beta is equal to 302 degrees. State to the nearest whole number. All bearings questions are different. The use of the sine rule and the cosine rule remains a constant. The difference is analyzing your diagram, looking for your corresponding angles, looking for your alternate angles if there are any. 9 times out of 10, I will say in bearings you will have corresponding angles. Where you see the opportunity to complete the sine rule for the triangle, take the opportunity and complete the sine rule for the triangle. If you see the opportunity to complete the cosine rule, try a thing. Don't wait until the exam to try a thing. Try a thing on your own so you will know, okay, it makes sense trying a thing here. Nah, it makes sense trying a thing there. Yeah. That the only way you'll get good is if you practice. I will forever preach this for all my students. Practice makes perfect, especially when it comes to maths. To know maths, you have to do maths. That's all the time we have for today. Thank everybody for coming out, supporting the channel. It's the best way for the channel to grow, and eventually we'll become big enough to educate a lot of people. So tomorrow I will post another schedule for tomorrow, and tomorrow we'll just be rattling off some past papers, doing paper 2s, paper 1s. I'll provide you all with solutions for them. We'll start with paper 1s because we can look up paper 1s real quick, and then we'll go into paper 2s. So look out for the reminder tomorrow. Make sure and put on your notifications for the channel. And yeah, I'll see everyone. Alright, Naveen, I'll answer your question there. After school, yes, Whitney, after school will be the stream. I know you'll have English tomorrow, so after English. Why I A instead of directly subtracting y from 360? If I subtracted y from 360, I will get the angle that is inclusive of A. The bearing starts from the north line to P. That is the angle I want. Right here in U2. So Naveen, I want that angle from the north line to P. If I draw it in a different color, this is the angle I want here. That angle there is part of a circle. The rest of the circle is here, y plus A. If I just take away y from it, I will have this angle here included in the bearing, and that's not how we measure the bearing. Oh, this will also be posted up, right? I'll post this directly after, so you can go and review it. Alright guys, well, I'll see everyone tomorrow. Keep practicing. Good luck in your English exams tomorrow, everybody. And Wednesday we will be having a stream as well, and we will be tackling the maths. Nice, not the complete external angle.